Students and especially general seekers of truth, we will work on this problem here that has to do with some application of the definite integral. And so let's read through this problem. Let's mark up the text of what's important, and then we will attack it, this question. Okay, so on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a processing plant is modeled by G of t. So first here, it is important to recognize that G of t is the rate at which gravel arrives. And it's only valid for t between 0 and 8. So this is the amount of gravel, or this is the rate at which the amount of gravel is coming into the processing plant. At the beginning of the workday, the plant has 500 tons. Okay, so 500 tons here is not a rate, it's the amount. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So, for your convenience, I have graphed this function here, g of t equals 90 plus 45 cosine t squared over 18. And this represents the amount or the rate of change the rate of change of the amount of gravel arriving. Arriving or incoming amount of gravel, and this is the rate of that. Now, let me draw you a second graph here. This would be the rate of gravel being processed. Okay. So G of t here represents the amount of gravel that is unprocessed, the rate of change of the gravel that is arriving unprocessed. The rate of gravel that's being processed would be exactly 100 tons the entire time. 100 tons per hour. Okay? This rate that's incoming changes a little bit as time goes on. Okay. So number one, explain the meaning of G of 5 and the meaning of G prime of 5. So for our answers, we can say that G of 5 means that the amount of gravel that arrives at the plant is changing at that given rate. And just so that we have something to talk about, let's just plug 5 into G and get ourselves a number. So I get that G of 5 is approximately equal to 98.141. So this means that at t equals 5, the amount of gravel that is coming in is changing at a rate of 98.141 tons per hour. At t equals 5, the amount of unprocessed gravel changes at a rate of 98.141 tons per hour. Well, what would be G prime of 5? Okay, so number 2 asks us that question. What would be G prime of 5? What does it mean? And let's give the exact units. So G prime of 5, and we can just plug this into a calculator, is approximately negative 24.588. And G prime here is the rate of change of the rate of change. G is the rate of change of the amount of unprocessed gravel. So G prime would be the rate of change of the rate of change. So we can interpret this in the following way, that at t equals 5, the rate of change of unprocessed gravel is decreasing. It is decreasing by, and the amount that is decreasing by is 24.588 tons per hour. because tons per hour is the rate of change of the amount, and we're talking about tons per hour. So we can say this is tons per hour squared. So I know this seems weird, but if we look at this here, this graph here, G, remember, is the rate of change of the gravel. And since G is positive, that means the amount of gravel is increasing. But because G is decreasing, we can say that the amount of gravel is increasing at a decreasing rate. Okay, so the amount is coming in, but the rate at which it's coming in is slowing down a little bit. Okay? And it's slowing down by this much when the time is exactly 5 hours. Now we're going to look at number 2, or no, I'm sorry, that was number 1. Now let's look at number 2. How much gravel is removed from the plant during the workday? Now keep in mind that this is a rate, and the units in here are tons per hour. So by analyzing the units a little bit, we can get a better sense of what to do with this. Well, we want the how much gravel here. The units for that should be in tons. Okay? So we have tons per hour here as the units of G of t. The units of time, which is along the horizontal axis here, is in hours. So if we compute the area underneath this curve, right? So if we compute like this area right here, this would give us tons, because you have hours times tons over hours, and that would result in tons. In other words, if you take the definite integral over a function that is a rate, then you'll get an amount. Okay, so we actually want to compute, during the workday is from 0 to 8, so we actually want to compute this entire area here. Now, I've said before that in the previous videos and parts of the lessons, that this lesson is not concerned with the intricacies of the computations. We just want to interpret what the meaning of this is. So the answer to number 2, let's write out our work here. This would be the definite integral from 0 to 8 of G of t dt. Okay, of G of t dt. Now, how do we do this, without knowing how exactly to deal with all the mechanics and the algebra of this? Well, we're going to use and rely on our TI-8384 calculator. So with my TI-8384 calculator, I've typed in the function already, 90 plus 45 cosine x squared over 18. And I'm just going to go ahead and exit out of this. Okay? And then I'm going to hit the math button. And then if you scroll down, it's option number 9, FNINT. You get the ability to enter in a definite integral. So we want to evaluate this definite integral from 0 up to 8. And this function here, I've already typed it into y1. So one thing you could do is just manually retype all of this, 90, 45 cosine x squared plus 18. Or you could also use the vars button here and just go to it and yvars function y1. Okay, so this is the equivalent of typing 90 plus 45 cosine x squared plus 18, and then make sure this d here that you enter in a dx, right? And then just enter, and it will evaluate that result for you, and we get 825.551. And so this is about 825.551, and the units here are in tons. So that helps us answer number 2. In other words, the amount of gravel that is arrived during the workday. Oh, I'm sorry, we answered a different question here. What a terrible mistake I made. This is not this is not the amount that is. Number 2 asks for the amount that is removed from the plant. What we just answered there is number 3, the total amount that arrived, because this graph here, G of t is the amount that arrives. Okay, so no biggie. We actually answered this question correctly. We just answered the wrong question. But hopefully, using that information, you can now answer number 2. Okay, so I will leave that to you. Number 2, do this on your own. And it's a much simpler calculation. You can actually do it without a calculator. It's perfectly possible to do that number 2 there without a calculator. Okay? What I'm going to do instead is proceed onwards to number 3. Excuse me, I'm going to proceed onwards to number 4. All right, so in number 4, we want to know how much gravel is actually at the plant when t is equal to 3. And so we have to take a lot of things into consideration. Okay, so at the start, the total amount that is at the plant, we know that at the start we had 500 tons of it, and we want to add the amount arrived. Okay. And then we want to subtract the amount that was removed or processed. Okay, so we want to subtract the amount that was processed or removed. A lot of people forget this 500 here as the starting amount that we had. And this is all between, t equals 0 and t equals 3. Right, between t equals 0 and between t equals 3. So let's work out all the details. This would be 500. The amount that arrived would be the definite integral from 0 to 3, because we want to know how much there is at 3, of g of t. Okay? And I've already talked about how to do this on a calculator, g of t dt, minus the amount that was removed. Well, what is the rate of removal? It's removing at a constant rate of 100 tons. So let's say we have a function r of t that represents the removal rate. Well, the removal rate is always 100. It's constant. So we're going to integrate from 0 to 3 of 100 dt. In other words, the removal rate function, the function looks something like this. It's always at 100. Right? So this would be r of t. And we're going to compute this area here between 0 and 3. So it shouldn't be too difficult to figure out. So this part, I'm going to do this on my TI-83, TI-84 calculator. And then this one, we already know this is just going to be 300 tons, because it's going at 100 tons per hour for 3 hours. And I started out with 500 tons. And then I'm going to work this out on my calculator. So after working all of that out on my TI-83 calculator, I get that this definite integral here is equal to 401.664. So finishing up all the arithmetic, this is 901.664 minus 300. So this is 601.664 tons, because we're talking about amount here. So we're talking about the how much gravel. So this is the amount of gravel that we have left in the plant. So what this example illustrates for us is how the definite integral applies in other contexts besides velocity, acceleration, and position. We have a rate here, just like we did before. G of t, again, let me remind you, is a rate. Just like in the previous examples, velocity was a rate. Acceleration is a rate. Here we have a rate as well. When we take the definite integral of the rate, we get an amount. Okay? And again, all of the mechanical stuff, the algebraic work, we're offloading right now to a calculator. We will worry about that later in this course. Right now, the key concern is, can you interpret all this information and make sense of it? As always, ask for help if you need it. Thank you for watching, and have a wonderful day.